Alright, this is module 34. Prove triangles are similar by angle or AA. So, first thing I have to do is I have to tell you what the AA similarity postulate is, or angle. And you can just basically say AA for short. It basically states that if two angles of one triangle are congruent to two angles of another triangle, the true triangles are going to be similar. You don't need to know anything else. Similar, not congruent. That's the main thing, because I know in a previous module, or Unit 4, we were talking about triangle congruence. Here, we are talking about triangle similarity. So, in this figure, I have angle J is congruent to angle X, and angle K is congruent to angle Y. If that is true, then you can say that the two triangles JKL are similar to triangle XYZ. Now, the thing you need to remember, again, when you're doing this, is your orientation. So, again, I went from JK to L, which is J to K to L. I have to do the exact same orientation with the other one, which would be X to Y to Z, which I do. So, the orientation needs to stay the same, just like it was in Unit 4. So, I have determined whether the triangles are similar. If they are, write a similarity statement. So there's two things that you have to do in this particular example. So first thing I see is I see a 90-degree angle. A 90-degree angle. Thing you have to remember from Unit 4 is the triangle sum theorem. All triangles add up to, or angles add up to 180 degrees. So we know that angle D is congruent to angle G. Those are right angles. Right angles are congruent. We know E is got to be 64. How do we know E is 64? Because if you do the triangle sum theorem, that means that you can subtract and solve and get this is 64. You could also do it with angle K if you wanted to. So, once we know that angle E is congruent to angle H, we can just say that the two triangles are similar by the AA postulate. All we have to do is just do two angles. We could do three, but two is all we need. So again, when you're doing this, CDE is similar to KGH. So if I went from C, the 26 angle, to the right angle, to the 64, I have to do the exact same thing with the other ones. This is probably going to be 26 because of the triangle sum theorem. Not probably, it is going to be. So I started 26, I have to go K to the right angle, G, up to 64, H, which I do with both of these. Okay, what about this one? So example A is a little tricky because it says show that the two triangles are similar. We have ABE, which is the small triangle here, and then we have ACD, which is the larger triangle. So looking at this, if you recall, there's actually a couple different ways of doing this. If you recall from Unit 3 that these two angles here being congruent, what can you state about these two lines? Well, if you know that the corresponding angles are congruent, by the converse, corresponding angles converse, you can state that these two lines are parallel. So if we know that, we also can state that these two angles are congruent as well by the corresponding angles converse. Now that's one way of doing it. So, okay, so since we know these two angles are congruent, we can state that these two triangles, I'm going to start at A, triangle A, B, E, and then I'm going to do the exact same orientation is to triangle A, C, D. That's by the angle similarity. So angle similarity postulate. Now the thing you can also state, and you wouldn't have to do corresponding angles. That's just kind of relating it to another unit, but this is also relating it to another unit. What do both triangles have, ABE and ACD? What do they have in common? Well, they have angle A in common. So by reflexive property, angle A is congruent to itself. So you can state, again, by angle, that the two triangles are congruent. So there's two different ways. Okay, what about the next one? We have two parallel lines cut by a transversal. That means you can say that this angle is congruent to this angle by alternate interior angles. You can also say that this angle is congruent to this angle by alternate interior angles. And actually, I can say that the third angle here is congruent to this angle here by vertical angles. So there's many different ways of doing this, but here's one. So we can say that angle SVR is congruent to UVT's angle by vertical angles. We can also say that angle S is congruent to angle U by the alternate interior angles. So the answer is going to be triangle SVR is similar to triangle UVT. Again, the orientation has to be correct by the angle-angle similarity postulate.